we've got a pretty good grip on multiplying fractions now, and so we've added them, we've subtracted them, we've multiplied them. Not surprisingly, we're on to division. I've never divided a fraction in my life, and probably neither have you, because there isn't a procedure for dividing numbers like this. What we do instead, when you're given something that's to be divided by a fraction, is this. You leave the first number completely alone, you change the division to a multiplication, and then you flip the second fraction over. So 3 over 14 becomes 14 over 3. There. That's what you do when you're told to divide. You don't. You change it to a multiplication, flip the second, and now you carry on as we taught you in the previous unit for multiplication. Let's see, can we reduce anything here? A little bit. This isn't really exciting, but we can do 10 divided by 2 is 5. 14 divided by 2 is 7. That helps a little bit. And now when we multiply, 7 times 7 is 49. 5 times 3 is 15, and that's us done. So all the rest of these are going to work like that as well. Whatever you're told to divide, you just change the division to a multiplication and flip what comes after. So this becomes 6 over 5 times 10 over 9 times 1 over 20. We'll do the reducing thing before we go on. 10 and 20, that's too good to pass up. 10 divided by 10 is 1. 20 divided by 10 is 2. 6 and 9, I can do 6 divided by 3 is 2. 9 divided by 3 is 3. And last thing, I've got 2 and 2 here. 2 divided by 2 is 1. 2 divided by 2 is 1. So what's left? 1 times 1 times 1. And downstairs, 5 times 3 times 1 is 15. Last one. 6/5 divided by, now that it's bracketed, there's two ways that you could handle this. The first one is you could change this to a times and flip both of these fractions at once. Or option 2 is we could work out what's in the brackets, crunch it down to a single fraction, and only then flip over the result. I don't even know which one I prefer. I think I'm going to do the first one just because it's a little bit more unusual and I want to show you that it really does work. So 6/5, we'll change this to a times, and now this entire fraction gets flipped, both of them. So we're going to get 10/9 times 20 over 1. Now, we're multiplying all of these together, so we should try to reduce before we go any further. Let's see, 10 and 5, that's easy enough. 10 divided by 5 is 2. 5 divided by 5 is 1. There's our 6 and 9 combo again. 6 divided by 3 is 2. 9 divided by 3 is 3. And I believe that's all we've got. So now if we multiply this, 2 times 2 is 4, times 20 is 80. And downstairs, 1 times 3 is 3, times 1 is 3. There's our finished answer. That didn't take a lot of space, so I'll actually run this one the other way, just so we can confirm that they both come out the same. Option 2 is 6/5 divided by, and I'm just going to do what's in the brackets, first of all. 9 times 1 is 9, and downstairs 10 times 20 is 200. This is following BEDMAS, our order of operations, that says whatever is in brackets, do that first. Now that we have done it, we do the thing where we keep the first number, change the division to a multiplication, and flip the second fraction. And now we reduce whatever we can. 6 and 9, we're getting used to seeing that. 6 divided by 3 leaves 2. 9 divided by 3 leaves 3. And 5 and 200 we can do as well. 200 divided by 5 is 40. 5 divided by 5 is 1. Now we multiply it out. 2 times 40 is 80. And downstairs, 1 times 3 is 3. So, same answer, that's nice to see. This second way is probably easier, I think. It's logical, it follows the Bedmas sequence, which says sort out whatever's in these brackets before you start the division. But I wanted you to see this top way, just so that you know that this can be done. You can flip an entire series of fractions if they're all affected by the same division sign.